Hey, it's Mr. Lum again, and today we're going to be learning how to calculate ion concentrations in a solution. So right here we have two examples. The first one here is manganese 2 chloride solid dissolving into manganese ions and chlorine ions in solution. So again, we're having an ionic solid dissolve and become ions in solution. So let's imagine that we had 1 mole of manganese 2 chloride. So we have 1.0 moles of manganese 2 chloride. When that dissolves, it's going to break apart and it's going to make 1 mole of this, and it's going to make 2 moles of this. Okay. Now if we had 1 mole of manganese 2 chloride in solution, and let's pretend our solution is a nice easy number like 1 liter, then what we would have is this be moles per liter, and since our fictional amount of volume is 1 liter, this would be 1.0 molarity. And the amount of manganese ions it would make is also 1.0 molarity, and this would be 2.0 molarity. Okay, because it's all happening in 1 liter of solution. Now, the reason this is imagine we have manganese chloride. So here is 1 particle of manganese chloride. So we have Mn right here, and then we have attached to it is with ionically attached to it we have chlorine. Now we have a whole bunch of these. We have many of these, but when this dissociates and becomes in a solution, what we're going to see is we're going to have 1 Mn2 plus, and we're going to have 2 chlorines. And what we see here is, and that's how we get this 1:1 to 2 ratio. So again, if we had many of these things, in other words, we had 6.02 times 10 to the 23 particles of this, or in other words, 1 mole of this, we'd have 1 mole of this, because this is a 1:1 to 2 ratio. So that's why we see twice as much there. Now, let's take a look at doing a question and using that principle. Now, this question says calculate the concentration of all the ions in solution of, or calculate the concentration of the ions in a solution of 0.25 molar FeCl3. So what we would see is if we'd have Fe, so iron 3 chloride, FeCl3, and that would dissolve and make and 3Cl minus. So if we had 0.25 molarity FeCl3, what's going to happen is that since it's a 1:1 to 3 ratio, when this dissolves, this is also going to be 0.25 molarity, and this is going to be, well, just multiplied by 3, 0.75 molarity. Okay, and this is just fine doing a calculation like this. That is completely fine. If you really wanted to see how it works, you could do the stoichiometry kind of calculation on this and go, well, 0.25 moles per liter of FeCl3, and then you would times this. Since it's a 1:3 ratio, you would go 3Cl minus divided by 1 FeCl3, and you'd see that this would cancel with this, and you're left with moles per liter of chlorine. And so 3 times 0.25, well, that's 0.75. Okay? But on a test or when you're doing your calculations, you don't have to show this thing right here. You can just show a formula and write something like that right there. Okay, here's a little bit different question. It says we have 25 milliliters of water is added to 20 milliliters of 0.35 molar Fe plus 3 ions, and what is the new concentration of this iron? So what we can do is we can take this and do a dilution calculation on it to calculate the new concentration of iron 3 ion. So what we can do is we can go 0.35 moles per 1 liter of Fe3 plus, and what we're going to do is we're going to change this into moles. So we're going to times this by the concentration right here, which happens to be 20 milliliters. So we're going to go times by, and we're going to change this to liters, so we're going to go times by 0.0200 liters. So that's what 20 milliliters is in liters. And then now we have moles of iron 3 ion. Now, we want to know the new concentration, so we don't want to know moles, we want to know molarity. So we're going to divide this by the new volume. So the new volume is 20 milliliters plus 25 milliliters, which is 45 milliliters, or in other words, 0.0450 liters. And if we did that, we'll find that we're going to get a concentration of iron 3 ion that is 0.16, 2 sig figs, 3 sig figs, 3 sig figs, so our answer is 2 sig figs, 0.16 concentration of Fe. And that's our concentration. You can also use, there's a formula that you can use if you want, but you don't need it, but it is your C initial, which is your concentration initial times your initial volume, or your V initial, and that is equal to your concentration final times your V final. Okay? Now, again, you know your concentration initial, because this, your concentration initial right here, is 0.35. Your volume initial is 20 milliliters. And your concentration final is your unknown, but your V final, you do know this one, and that is, well, 20 plus 25 is 45 milliliters. Okay, so you can use this formula as well. This formula is the exact same thing as this right up here. So another question that we have here is when we are mixing two different concentrations of two different solutions together. So we have 10 milliliters of 0.1 molar barium nitrate, and this is mixed with 40 milliliters of 0.300 molar silver nitrate. And it says calculate the concentration of nitrate. So the first thing that I think we should try doing is write out some formulas. So here is barium nitrate, and when this dissociates, it's going to make barium ions and 2 nitrate ions. Okay, and the other formula that we're going to be dealing with is silver nitrate. So silver nitrate, AgNO3, is going to dissociate and make silver ions and nitrate ions. Okay, so again, this one starts off with 0.100 molar, and since it's a 1:1:2 ratio, you know that this is going to be 0.100 molar, and this is going to be 0.200 molar, and this is going to be 0.300 molar, and since it's 1:1:1 ratio, this is also 0.300 molar, and this is 0.300 molar. Okay, and what we can do now is, just since we want to know these nitrate concentrations, we're going to find out, we're going to do a dilution calculation on this one, and then add it up. So what we see here is if we take this one right up here, so I'm just going to draw a little kind of arrow. So we're going to go 0.200 molar, and we're going to times this by its initial volume, so times by 10.0 milliliters, divided by the total volume after we add everything up, so 10 plus 40, and we get 50 milliliters. Okay, and if we do this, we see that you're going to get a concentration, a diluted concentration of this nitrate that came from the barium. Now, what we're going to do is we're going to add this to this nitrate after it's been diluted. So here is this nitrate right here after it's been diluted, and this is going to be 0.300 molar times, now its initial volume is 40 milliliters, and the new volume is 50 milliliters. So we're going to add these two things up, and what we get is, I already did a calculation on this, and we get 0.280 molar of nitrate.